Hello to all those watching this video. My name is Kerishnee Naicker and I'm currently an intern at the Central Analytical Facilities at Stellenbosch University. And for this video, I will be showing you how to use FIJI or ImageJ to process your microscopy images. FIJI is a very powerful technique that can be used for various different types of processing, such as deconvolution, tracking of particles, analysis of particles, and many more. This video is focused on how to use FIJI to analyze your particles and how you can use it to segment cells that appear to be joining. Firstly, you would need to know how to load your image onto FIJI. There are three different ways in which you can do this. The first is to drag and drop your image. The second is to import your file, in which you go to File, Import, and Image Sequence. You can thereafter choose which image you would like to analyze. And thereafter press OK. The last way in which you can do this is by clicking on File, Open, and thereafter you can choose the file that you'd want. Once you have your image open, you can continue. In this example, I'm using mycoplasmas, and you can see that the image does not look at its best. It's a bit blurry and also out of focus. This is because the image was taken on a wide field microscope. I will be using this image to show you how to analyze your particles and a different image to show you how you can segment your particles. As this is a color image, in order to analyze your particles, we would first need to convert this image to an 8-bit image because it would be easier to process this compared to an RGB image, as the size of the file would decrease. To convert this to an 8-bit image, you would click on Image, Type, and 8-bit. Thereafter, we would need to define the image by differentiating between the nuclei and the background by using the threshold function. You can find the threshold function by clicking on Image, Adjust, and Threshold. If you are happy with how your image looks, you can click Apply. The dark background is usually ticked if you do have a dark background. If you don't have a dark background, make sure that is unticked, and that's what it would look like. In this case, I do have a dark background, so I'm just going to leave that ticked and click on Apply. I could thereafter exit this. The threshold function is usually used to select the areas of interest in an image and ignore the parts that we are not interested in. As you can see, the threshold function clearly marks the nuclei in which I am interested in. So once this is complete, you can thereafter analyze your particle. Analyze particles. Thereafter, this box would show up. You can choose the size of the particles you are looking for. In this case, there would be different sizes, so I would leave it 0 to infinity. Circularity will allow you to choose how circular your particles should be. The tab that the Show tab also allows you to choose how you would like your final image to look. In my case, I would like to show the outlines and thereafter display results as well. So once you are happy with what you have chosen, you just click on OK. And thereafter the image would show you onto which different particles correlates with the different analysis in the table. So as you can see, the drawing of the final result looks a bit too big. So what you can do to minimize this is by pressing on Control and the Subtract button. And thereafter you have example is whereby I will be explaining on how to segment your cells. You can see in this image that these two cells appear to be joining, and in order to perform analysis of each of the cell, you would need to know where these cells separate to continue. Once again, we would require the threshold function, but in order to use the threshold function, your image needs to be an 8-bit image, which can be converted by pressing Image, Type, and 8-bit. We can thereafter use the threshold function, Image, Adjust, and Threshold. And as you can see with the threshold function, these actually look as if it's joining. So you can just click on Apply and exit that. Now that your threshold function has been applied, you can use the watershed function to separate your cells. In this version of FIJI, there are two different watershed functions. One can be found under process, binary, and watershed. The next can be found in plugins, watershed and watershed segmentation. So the difference between these two is that they perform the same function but for different types of images. The one that's under process, binary, and watershed is used for black and white images, whereas the one that's in plugins is used for grayscale images. Since this is a black and white image, we would use the one that's under binary. So once again, you go for process, binary, and click on watershed. As soon as that is done, you see that there is a line that is drawn in between these two cells. So to have a closer look, we can just press on Control and the plus sign. There. As you can see, that there's a line drawn in between these two cells, and that's where you know your cells separate. Now, how does the watershed function work? Imagine bodies of water sitting next to each other, and as they fill, the two bodies of water would touch at a certain point, indicating that this is the end of the two bodies of water. The watershed function works as the same. Imagine the two cells are being filled with the water, and as soon as the two bodies of water touch, it indicates that it is the end of the cell. Once you are able to distinguish between your cells, you can thereafter process your images further. So this is all from me for this video, and if there are any questions or concerns, you are welcome to contact us on our website, and thank you for listening.